Hello friends, today we will see our third lecture of Basic Electronics module, which is Introduction to Resistors. So in today's session, we will introduce you with the resistors and its SI unit, its formula, its series and parallel collection, and its coding. So let's first start with Introduction to Resistors. So this section is divided in four categories, which are: first is resistor introduction, then we will see series and parallel connection of resistors, then power dissipation and different types of resistors, and in the last topic we will see color coding and applications of resistors. So let's first start with the basic introduction of resistors. So what is resistor? So resistor, the name itself suggests it is something which is going to resist. So a resistor in a circuit is used to resist the flow of current or to limit the current flowing through it. So a resistor is a passive two-terminal electrical component that implements electrical resistance as a circuit element. So in electronic circuits, resistors are majorly used to reduce current flow, adjust signal levels, to divide voltages, bias active elements, and terminate transmission lines. So these are the basic applications in which resistors are used. So it's SI unit and its symbol. So the SI unit of resistor is ohms, and as you can see in the box, this is how its SI unit is represented in symbolic way. So as you can see in the picture, there are three different schematic representations of a resistor. The first one is a simple resistor, which is denoted by A representation. Then after that there is a B representation, which shows a schematical representation of rheostat, which is nothing but a variable resistor. Then after the C image is for potentiometer, and there is a box, rectangle box is sometimes used to represent a resistor in a circuit. So below are two typical schematic representation of resistor. So SI unit is ohms and it is represented by this symbol. Now this is the representation of resistor. Whenever a resistor is represented this way, the R1 and R2 defines its symbolic value. Then the schematic representation is the both of them below R1 and R2, that is nothing but a schematic representation. Then thereafter 1 kilo ohm and 47 kilo ohm is the numeric value of that particular resistor. 1 kilo ohm is of R1 and 47 kilo ohm is numeric value for the resistor 2. So this kind of R1 and R2 representations you can see on many of Arduino, or you can say Raspberry Pi modules or PCB. In each and every PCBs, the resistors are defined or represented by R1, R2 up to the number of resistors used in that particular PCB. So R1 and R2 denotes nothing but the number of resistors in a circuit. R1 means the number 1 resistor, R2 is number 2 resistors, just to define separate two resistors. Now the SI unit for resistor is ohm. So what is Ohm's law and where it is used, and what is its significance? So the behavior of an ideal resistor is described by Ohm's law. So what is Ohm's law? So Ohm's law states that the voltage across a resistor is proportional to current passing through that particular resistors. Means whatever voltage is across that resistor is always proportional to the current flowing through the resistor, where the constant of proportionality you can replace it with resistance. So the as the Ohm's law statement represents, voltage is proportional to current. So voltage proportional to current and that proportionality constant is replaced by nothing but resistance, and it gives us the Ohm's law formula, which is nothing but V is equals to I into R, where R is the proportionality constant, which is resistance. Now 1 ohm will be described as, so as you can see, V is equals to I into R, so R will be equal to voltage divided by current flowing through it. So whenever you want to find the value of resistor, you can use this equation V divided by I. So an ohm is equivalent to a volt per ampere. For example, if a 300 ohm resistor is attached across the terminal of 12 volts battery, means there is a voltage of 12 volt and the resistor of that particular resistance is 300 ohms, then the current flowing through that resistor will be equal to I is equals to V by R. So voltage across that resistor, which is 12, and the resistance of that resistor is equals to 300. So the current flowing through that particular resistor will be equal to 12 divided by 300, which will be equal to 0.04 amperes, because current is measured in amperes while voltage is measured in volts. Similarly, the resistance is measured in ohms. Now moving forward with the connection, different connections of a resistors. There are two types of resistant connections, which are series and parallel. So resistors are connected either in series or in parallel in any circuit. So this the section flow is what is the series connection, then after the formula and connection of series connection, then what is parallel connection, its formula and connection, and their advantages and disadvantages. So as you can see in this image, the resistors in series, they are connected this way. So this is R1, this is R2, and this is R3 to up to Rn minus 1, and then this is the next, or you can say the last resistance in the network. So in this network, as you can see, the resistance R1 and R2 share a common node over here. So the last node of this R1 and the very first or the beginning of this R2 are connected together. So in series connection, there is only one common node, and one common node is common throughout this section. So here R1 and R2 shares this common node, while R2 and the R3 somewhere here is sharing this common node, while the Rn and the resistor before it Rn minus 1 shares somewhere here. So there is only one common node in series connection. So the formula for the series connection of resistor will be, or you can say the total of this series connection would be equal to the sum of R1 plus R2 plus R3 plus up to Rn, which is the last resistor in the network. So in series connection, the resistors share a common node and current through all the resistor is same. So here, as you can see, as I said earlier, in series connection, the resistors shares only one common node. But as you can see from this diagram, the current enters through this node or this point have only one path to flow through, means the current flowing through each resistor is similar for the whole network. The current coming through this is going through R1, R2 up to Rn and leaving the network through this node. So there is no change in current throughout the network. The current in this series connection is similar in each equipment in R1, in R2 and R3. So there is no change in current. The total resistance of resistor connected in series is the sum of their individual resistance value. Means the R total, means the total resistance of this network is nothing but the algebraic sum of individual resistor R1 plus R2 plus R3 up to Rn. From the above equation, it is clear that the effective or total resistance of circuit is increased when resistors are connected in series connection. Hence, in order to increase the circuit resistance, the resistors should be connected in series. So whenever you want to increase the circuit resistance, then you will have to connect the resistors of that network in series connection. Now, talking about the advantages and disadvantages are, same current flows through the every device. So as you can see in this network, the current is similar in each of the component. Only one pathway, means the current has only one path to flow through. If breakdown or fault occurs in one device, it will affect the other devices in the circuit as they are connected on the same branch. So this is the disadvantage or the main drawback of series connection, which is, see, as you can see here, the current flowing through each and every component is similar because current has no other path to flow through. So if in case the fault occurs in this section or this component, the current will not be able to go beyond this. So the current through the latter components, means in R2, R3 and Rn, will be stopped because of the fault in this section. So there will be no current flow through these devices and hence the whole network will be shut down. So this is the drawback of series connection when fault occurs in any. If fault occurred in this, then the latter components after R2 will be off or will be shut off due to no current flow through them. These are used where same current and different voltages are required. Means whenever you want the same current through the devices but different voltage, then you will have to go for series connection. Now another is resistors in parallel. So this is the some schematic representation of resistors connected in parallel connection. So this is how resistors are connected or gets connected in parallel connection. So as you can see from this network, each and every resistors share at least two common nodes. See, R1, R2, Rn share this common line. Also, similar R1, R2 and R3 sharing this common node. So, in each and every parallel connection, the equipments or the resistor or the components share at least two common nodes. So, the current has more paths to flow through. Suppose the current is coming from this node, then from here at this node the current has option, means some percentage of current will flow through this and the remaining current will flow through this branch. Means the current has more than one path to flow, means more than one pathway available in parallel connection. So you can say the network or this connection has the total resistance this way. The inverse of R total, the total resistance of the network R total will be equal to the summation of individual inverse of resistance. So in parallel connection, the resistors in parallel share two or more common nodes and voltage across each resistor is same while the current is different. So as you can see from this network, the current has more than one path to flow, but the voltage across each, means voltage across R1 is equals to voltage across R2, which will be equal to voltage across Rn. So voltage across each and every component or say resistor is similar in parallel connection, but the current flowing through them is different. The total resistance of resistor connected in parallel is the reciprocal of the sum of the reciprocal of the individual resistors. From the above equation, it is clear that when the resistors are connected in parallel, the effective or total resistance of the circuit decreases. Hence, in order to decrease the resistance of circuit, the resistors should be connected in parallel. So whenever there is a requirement of less resistance or decreasing the resistance, you will have to go for parallel connection. Now, discussing its advantages and disadvantages. So as we discussed earlier, it has same voltage drop but more pathways for current to flow. So same voltage drop but two or more pathways. So now the third topic is its advantage, main advantage of parallel connection. If breakdown or fault occurs in one branch of device, it would not affect the devices in other branch, as the other devices are on the different branch. As you can see in this network, if the fault occurs in this network or in this section or this particular branch, the current has the other branch or other path to flow through. Hence, the equipments or the components without faulty section will turn on or will remain in their position as before. So the fault or say faulty in R1 section would not affect anything in R1 and R2, and similarly between R2 and R3. So this is the main advantage, that fault in any section would not affect other section as well. Hence these are used where constant voltage and large current is required. So the parallel connections are always required when constant voltage and current are necessary. For example, in our house and commercial wiring. So we have a housing and commercial wiring in parallel connection in order to maintain uninterrupted current and voltage throughout the wiring or component sections. So in housing and commercial wiring, the parallel connection is best. After seeing the series and parallel connection of a resistor, we will move forward with power dissipation and the types of resistors. So the flow of this topic would be power dissipation, then the different types of resistors, then fixed resistor, variable resistors, and working of variable resistors. So first is, what is power dissipation? So first of all, power dissipation is something which is we can call as an undesirable quantity. So at any instant, the power P volts consumed by a resistor of resistance R is calculated as, so we know that power P is equals to voltage into current. So voltage across the resistance into the current flowing through it is referred to as power in volts. So power P is equals to V into I, or is equals to V square by R, or is equals to I square R. This is the common formula for power. Now this power is converted into heat, which must be dissipated by the resistor's package before its temperature rises excessively. So resistors are used to dissipate a power. Resistors are rated according to their maximum power dissipation. Now, different types of resistors. Which are the types of resistors? So here the fixed resistors are falls into these categories, which are further divided in lead arrangements, carbon composition resistors, carbon pile resistors, carbon film resistors, printed carbon resistors, thick and thin film resistors, metal film resistance, metal oxide film resistance, wire wound resistance, metal fossil resistors, emitter shunt resistors, and grid resistors. These are the fixed resistors. But now, what are variable resistors? So see, in fixed resistor, the amount of resistance you cannot vary. They just come in different forms, but the value of resistors remains constant for the throughout the operation. But in variable resistors, you can vary the value of resistance according to your need. So the variable resistors are further classified in adjustable resistors. Means the value of resistors you can adjust. A resistor may have one or more fixed tapping points, so that the resistance can be changed by moving the connecting wires to different terminals. So in this type of resistors, you can change the value of resistance by moving the connecting wires to the different terminals. Some wire wound power resistors have a tapping points that can slide along the resistance element, allowing a larger or smaller part of the resistance to be used. Means according to our need, we can increase or decrease the resistance element, and according to that the value of resistance will change, will increase or decrease. Where continuous adjustment of resistance value during operation of equipment is required. The sliding resistor tap can be connected to a knob accessible to an operator. Means using a knob you can vary that resistors. Such as a device is called rheostat and has two terminals, and these are emitter shunts and grid resistors. So these are the different types of variable resistors: rotary POT, dual gang POT, singleton POT, concentric POT, multi-ton POT, servo POT, tremor POT, digital POT, preset POT, linear POT, and slide POT. Now the second category is potentiometer. As we discussed earlier, a potentiometer is also a variable resistor. So it is a three-terminal resistor with a continuously adjustable tapping point controlled by a rotation of a shaft or knob or by a linear slide. So as you can see in this image, there are three terminals A, B and C, and there is also a rotating shaft or knob through which you can vary the value of resistance. The name potentiometer comes from its function as an adjustable voltage divider to provide a variable potential at terminal connected to the tapping point. Now at tapping point the value of voltage varies according to the variation in the resistance value. So it is also called as potentiometer. Volume control in audio device is a common applications of potentiometer. So these potentiometers are used in volume control knobs in audio devices. So this is how your potentiometer looks like. There are three terminals in potentiometers, where one is ground, another is output, and another is for VCC. Means through this terminal you will provide supply. Through the ground terminal you will connect the potentiometer to ground, and to the from the output or output terminal you will get the output. And this is how they are connected. VCC and ground are connected through a resistor, and output is getting or vary from here. Now, working principle of potentiometer. The basic principle of potentiometer is that potential drop across any section of wire will be directly proportional to the length of wire. Means the length of wire will decide the potential drop, provided the wire is of uniform cross-sectional area and a uniform current flows through the wire. Means these are the must quantities of that. The wire should be uniformly cross-sectional area, and a wire should have the uniform current flow through it. So these are the basic necessity of a potentiometer. Means the basic necessarily aspects which it should have consist of. The potentiometer is an instrument used for measuring the unknown voltage by comparing it with the known voltage. It can be used to determine the EMF and internal resistance of the given cell, and also used to compare the EMF of different cells. The comparative method used by potentiometer. The reading is more accurate in potentiometer, so you can rely on potentiometer to check or to measure unknown voltage by comparing it to the known voltage. So it is a reliable and an accurate instrument. Now moving ahead with color coding and application. The last part of our section is color coding and application. So this is how color coding works. As you can see in image, there are three different types of resistors available in market. The first one is 4-band color code. Second is it has 5 band of different colors, and the last one is it has 6 different bands of color code. And through this algebraic and mathematic operation, you can find the value of the resistor, which is kind of unknown. If the resistor is given to you and you don't know the value of the resistor or how much ohms it has, so you can define it, or you can check or estimate the value of that resistor by its color coding. So on first digit, if it's a black wire, then it is 0. If it is brown wire, then it's 1, 2, 3. According to the color, it has a different numbering system, and this is how it goes. You will select this the first digit, second digit, and third digit according to its color. So write down the particular number over here, then multiply. You will multiply by this, and you will add this tolerance to that previously calculated digits, and this is how you will correct, or you will get the value of your unknown resistance. Now the applications of resistors. So where are these resistors used? So it has a wide range of applications, such as circuit functions in LEDs and transistors, to divide voltages, and as an heating elements. So these are the mainly or majorly divided resistor applications. So we will see in depth. So first is a resistance used as a knob. So there are different types of resistor that work according to this usage range, and in this we can set the resistance value by using a kind of feature called knob. So using knob, you can vary the resistance, and you can use it as a volume controller, loudness controller, or controlling the speed of motor. Any change in resistance value affect the flow of current inside the circuit. So if you are increasing, you are controlling knob, and as per your controlling knob will change the flow of current inside the circuit. So this change in knob circulation will change the flow of current inside the circuit, and as an output it will increase or decrease the value of resistance. So the use of resistor in circuit functions are as a knob in a controlling the speed of motor, the pitch of musical tone, or the loudness of an amplifier, or as you can say in radio or anything, you can change the volume in your speakers. You can also change the volume of your output. Now the second one is to overcome the danger of equipments burning out. You can use a resistor. An overflow of the current through LEDs and transistors can be very dangerous. So an electric component called resistance is employed to overcome this danger. Also, LEDs and transistors are very sensitive to electric current. So the use of resistors in the circuit will help the LEDs and transistor and other various types of this type of semiconductors to function in the required current range. Ideal for them means by employing the resistor with LEDs and transistor will limit the current passing through the LEDs and transistor and similar other devices, and it will not burn out the device or component. So for safety of for operating it safely, we can employ the resistors. Now third one is to use your resistor as an heating element. Now you all know that whenever a current flows through device or component or say resistance, it will produce heat. So this production of heat, you can use that in some advantageous role. So because of a collision of ions inside the material, some obstruction generates is the resistance, and this in turn produces a lot of heat when conducting current. So we find the use of resistor in a heater, toaster, microwave, electric stove, and many more heating appliances. In a light bulb, the metal filament glows white hot due to very high temperature produced from the resistance when electricity is passed through it. Now the last application is dividing voltage. So to divide the voltage at a particular node or in particular device, you can use a resistor to divide the voltage. So dividing the voltage or the potential difference works when some components are required to operate in a much lesser voltage than the supplied input voltage. So connecting a resistor in a series will add in dropping the voltage across each resistor equally, thus helping the appliances for smooth work, which works in those conditions. So for smoothly operate an device or such a component, you can use a resistor to divide the voltage for its safety operation. So this was the some applications of resistors, and here is the end of our today's lecture. So thank you so much.